In this video, I'll show some of the inner workings for the modular synth setup that I was demonstrating in the previous video. As usual, I've only done a minimal amount of setup using the Midi Bridge software. I've given each cube its own unique color so that we can tell them apart, and MIDI channel so that our code can tell them apart. So they're sending data on channels 2 through 4. And the last thing I did in Midi Bridge was to turn on the distance detection for each face of each cube. And so you can just do that by turning on the CC options after you zoom in on a given face. And again, that's for each face of each cube, so just make sure you've got them all set up properly. I like to keep the Midi Bridge setup simple, especially when we're working with a programming environment like Reaktor, and we can just do all of the MIDI handling inside Reaktor, and it saves us a bit of time, and it makes it a little more flexible later on if you want to change things. Okay, so let's take a look at the Reaktor ensemble from the previous video. It consists of 3 instruments. And the first instrument is a sequencer that is a part of the Reaktor factory library. We're just using it to send notes to the synthesizer, and you could replace this if you wanted to load Reaktor inside of Ableton or something and just send MIDI data directly from one of the Ableton sequencers, but I just have this in here since we're using Reaktor standalone at this point in time. Our next instrument is a Midi Handler. And this is basically just accepting all of the incoming MIDI data from our master cube and making some sense out of it, determining which cubes are pointed towards which other cubes and how close they are, all that good stuff that we can figure out using the AudioCubes. And an important aspect of this is you can see in the Connect tab of properties that we have the MIDI input channel set to Omni, which means it'll receive data on all MIDI channels. So this is important because, as I mentioned earlier, our cubes are broadcasting on MIDI channels 2 through 4. So we're just receiving all of that data. And our final instrument is the synth itself. You'll see it's receiving all of the outputs from our MIDI receiver, and it's also taking incoming MIDI on channel 1, which is the MIDI channel that our sequencer is going to be sending data to. So this synth will ignore all of the incoming data on channels 2 through 4 that our cubes are broadcasting on. So it's an easy way for us to just split those signals apart. So the MIDI handlers I've shown you before. Each cube has its own macro representation that outputs the data that connects that cube to any other cubes. So these top 2 outputs tell us the faces of other cubes that we're receiving data from, and the bottom 2 tell us the distance to those other cubes. And we'll use this data to control our modular synth. So let's take a look at that next. The synth also contains a macro for each cube, and the macro will receive all of the MIDI data that's pertinent to that audio cube. So here we're receiving all of the data pertaining to cube 4. And we'll use it to route the oscillator coming out of this macro to the other oscillators to cause modulation effects. And all of that work is taken care of in this macro here called modular. It's taking our oscillator signal and the faces of the other cubes that we're pointing towards and the distance to those cubes. And we're going to use them all to route our signal where we want to go. So the MIDI data that tells us whether or not we're pointing towards a face of another cube, we're going to be receiving values between 0 to 4 for these, and we'll use them to control a selector module. The selector module is sending out our oscillator if we're pointed towards face 1, 2, or 3 of another cube, And remember that pointing towards face 4 does not cause us to broadcast towards another cube. The distance values here are being used to control the amplitude of our oscillator when it's being used as a modulator. So we're basically just taking the value, scaling it up somewhat, translating it into an amplitude, and then we're using the low-pass filters to kind of smooth out any sudden changes in the distance value here. So if you're moving the cubes really quickly, it'll just kind of slow it down a little bit to create a smoother transition. So that's how all of the audio is being routed between the various oscillators in our previous video, how we use the cubes to connect the oscillators to each other and to modulate each other. Showing how to build the oscillators themselves is a little beyond the scope of this tutorial, but I have a ton of free written and video tutorials up at ADSR Sounds about creating oscillators from scratch in Reaktor. So check those out if you're interested. Okay, so hopping up a level to our instrument view, we can see how all of these oscillators interact with each other. Each one has 6 audio outputs, and these are routed using send and receive modules back to our other oscillators. So here I have highlighted all of the modulation that the oscillator controlled by cube 4 is sending to cubes 3 and cubes 2. And you can tell by their names what they're doing. For example, 4-2 phase is going from cube 4 to cube 2 and modulating the phase of that oscillator. Okay, so that's basically it. The output from the oscillator controlled by cube 2 is sent to our speakers and to a scope module, so we can take a look at the waveform that we're creating. Alright, so that's how I built my basic modular synthesizer with the AudioCubes. Thanks for watching.